Between October 1 and October 5, 2015, a stalled atmospheric moisture transport system delivered rainfall across portions of South Carolina that exceeded design parameters for municipal drainage infrastructure, reservoir spillway capacity, and floodplain assumptions. The event proceeded as a continuous saturation failure rather than isolated flash flooding. The South Carolina coastal plain and Piedmont regions operate under average annual rainfall of 1,150 to 1,270 millimeters, distributed across approximately 110 precipitation days. Municipal stormwater systems in Columbia, Charleston, and surrounding counties were designed for intensity duration curves based on historical 24-hour maximums ranging from 150 to 200 millimeters for 100-year events. River systems, including the Congaree, Wateree, and Santee, drain through low-gradient terrain with limited channel conveyance and extensive lateral floodplains. Soil infiltration capacity varies. Sandy coastal soils permit higher rates, while Piedmont clay substrates reach saturation rapidly. Baseline conditions prior to October 2015 reflected normal seasonal moisture levels with no antecedent drought or saturation. A low-pressure system positioned offshore merged with an upper-level trough on September 30, establishing a persistent southeasterly flow from the Atlantic Ocean. Atmospheric moisture content exceeded 50 millimeters of precipitable water, well above the regional mean of 35 millimeters for early October. A stationary front oriented northeast-southwest across the state prevented inland progression of the moisture plume. Sea surface temperatures in the adjacent Atlantic remained elevated at 27 to 28 degrees Celsius, sustaining evaporative flux into the approaching air mass. The configuration locked moisture transport into a narrow corridor over the eastern two-thirds of South Carolina for a period exceeding 96 hours. Rainfall began during the evening of October 1 across the coastal plain, with initial rates of 10 to 15 millimeters per hour. By October 2, coverage expanded inland, and hourly intensities increased to 20 to 30 millimeters in localized cells. The precipitation was not uniformly distributed. Certain zones recorded sustained rates, while adjacent areas received intermittent, lighter amounts. Peak intensities occurred on October 3 and 4, with isolated hourly rates reaching 40 to 50 millimeters. The event was characterized by prolonged moderate to heavy rainfall rather than short-duration extreme bursts. Spatial extent covered approximately 25,000 square kilometers, with the heaviest totals concentrated in a band from Charleston County northwest through Richland and Lexington counties. Initial rainfall infiltrated normally through the first 12 to 18 hours. By the morning of October 2, clay-based soils in the Piedmont reached field capacity. Surface ponding appeared in low-lying zones by midday October 2. Sandy coastal soils maintained infiltration until October 3, when prolonged input overwhelmed vertical drainage. Saturation progressed from surface layers downward, eliminating storage volume in the vadose zone. By October 4, the majority of affected watersheds exhibited saturation excess overland flow, where additional rainfall converted directly to runoff regardless of intensity. Soil moisture sensors in Columbia registered values exceeding 95% of field capacity. The transition from infiltration to surface runoff occurred over a 48 to 60-hour period. Stream and river stages began rising on October 2 as runoff from saturated uplands reached channels. The Congaree River at Columbia recorded an initial rise rate of 0.3 meters per hour during October 3. Tributaries including Gills Creek, Crane Creek, and the Saluda River reached bankfull stage by the evening of October 3. Synchronization of peak flows from multiple tributaries occurred on October 4, when the Congaree exceeded its previous record stage of 9.75 meters, reaching 10.57 meters. The Wateree River near Camden and the Black River near Kingstree also exceeded historical flood stages. Flow velocities in urban creeks increased from baseline 0.5 meters per second to 2 to 3 meters per second, transporting debris and eroding unarmored banks. Stormwater conveyance systems in Columbia, Charleston, and Sumter were designed for 50-year and 100-year storm durations of 6 to 24 hours. Cumulative rainfall by October 4 had exceeded 400 millimeters in multiple urban centers, surpassing design storm totals. Inlets became submerged, eliminating hydraulic head necessary for gravity drainage. Pumping stations in low-elevation districts of Charleston experienced mechanical failure as floodwaters inundated electrical components. Detention basins filled to capacity by October 3 and ceased providing storage. Street flooding persisted for 48 to 72 hours in areas where drainage could not clear between rainfall pulses. Combined sewer systems in older urban cores discharged untreated overflow as inflow exceeded treatment plant capacity. Interstate 95 segments in Clarendon and Sumter counties were submerged under 0.6 to 1.2 meters of water by October 4, severing north-south highway continuity. Interstate 26 near Columbia experienced closures as the Congaree overtopped approach embankments. State highways 378, 601, and 76 were impassable due to bridge overtopping or road washouts. Rail lines operated by CSX and Norfolk Southern suspended service as ballast undermining and track misalignment occurred in flooded sections. Columbia Metropolitan Airport recorded standing water on taxiways but maintained runway operations. Approximately 550 road segments across 15 counties were closed by October 5. Bridge scour damaged 73 structures, requiring inspection before reopening. Duration of closures ranged from 3 days to several weeks. Electrical substations in flood-prone zones lost function as water levels reached transformer bases. Approximately 30,000 customers in the Columbia area experienced outages by October 4. The Canal Water Treatment Plant in Columbia, which provides water to 375,000 residents, shut down on October 4 when floodwaters from the Congaree River compromised intake structures and inundated chemical treatment areas. Boil water advisories were issued across Richland, Lexington, and Kershaw counties. Wastewater treatment facilities in low-lying areas experienced inflow that exceeded design capacity by factors of 2 to 3, resulting in bypass of primary treatment. Natural gas distribution remained functional. Telecommunications infrastructure experienced localized outages where floodwaters reached equipment cabinets. Floodwaters remained above ground level in portions of the coastal plain and Piedmont for 5 to 10 days following the cessation of rainfall on October 5. River stages receded slowly due to limited downstream gradient and continued inflow from upstream drainage. Standing water in urban areas prevented reoccupation of structures and restoration of services. Prolonged inundation caused foundation damage, mold proliferation, and loss of building contents. Agricultural fields remained submerged, destroying crops and soil. Roads required debris removal and structural inspection before reopening. Water treatment restoration required 11 days for full capacity resumption. The extended duration of inundation magnified economic and service impacts beyond those attributable to peak flood levels alone. The National Weather Service recorded maximum rainfall totals of 686 millimeters at Mount Pleasant and 542 millimeters at the Charleston Airport over the October 1 to 5 period. Columbia recorded 434 millimeters. These totals represent return intervals exceeding 1,000 years for the 5-day duration. The Congaree River at Columbia reached a stage of 10.57 meters, surpassing the previous record from 1936. The event was classified as a 1,000-year rainfall event for the affected region. 19 fatalities were confirmed, primarily from vehicle submersion in floodwaters. Estimated economic losses exceeded $1.5 billion. Federal disaster declarations covered 26 counties. The event was cataloged as the wettest multi-day rainfall event in South Carolina's instrumental record.